In this video, I'll be working on lab number 13 from the Flackbox.com Cisco CCNA lab guide, which is a free download. This is lab 13 and it's DHCP configuration. It says in this lab, you will perform a DHCP configuration for a small campus network. You will configure a router's outside interface as a DHCP client. You will then set up DHCP services, DHCP services using a Cisco router first and then an external DHCP server. The external DHCP server is inside the campus LAN but outside the router. Note that the external DHCP server at 10.10.20.10 will not be used until the last part of the lab. So we start with Cisco DHCP client. And it says you have not acquired a static public IP address from the internet service provider, which is here. Configure the outside interface fast Ethernet 00 on router 1, which is here, to receive its IP address using DHCP. The service provider is already configured and you have no access to it. So we just need to be able to set this. You're not typically going to have a router as a DHCP client. Except for in a case where it's to the outside to its IP, picking up its IP address from the service provider. That would be a time where you would do that. So it says you've acquired it. Configure the outside interface. So that's fast Ethernet 00 on our run and to receive an IP address using DHCP. So let's start with that. And we are on router 1. And we will go into global configuration mode and we're going to work on interface, nope, not gig, fast. And it was 00, yes. And then the command is IP address. So typically you would, when you're assigning an IP address to an interface of a router, you would then go type in the IP address, 10.10.10, whatever. But in this case, you just have to type the command DHCP. So it knows to pick up the IP address that way. And then we issue the no shut command to bring the interface up. And we should see that in Packet Tracer. Yes, it's come up. And so let's do a show, show IP interface brief. And let's see if it's picked it up yet. So 00 is unassigned at the moment because spanning tree is still thinking, so to speak. We're going to just fast forward in time a little bit. There it goes. They're both up. Let's repeat that. Do show IP interface brief. And still unassigned. So there it goes. It just popped up. Was assigned DHCP address 2030.113.2. And so let's verify that here again with the do show IP interface brief. You can see 00 has 2030.113.2. And the method that it was assigned was via DHCP. So that looks good. The other thing that we'll want to do is we can also look at this by doing a do show DHCP lease command. And it'll show us here the address is 2030.112.2 or .2, and it's at /24. And the server, DHCP server, is at 2030.113.1, which is the internet service provider. So we've taken care of step 1. Step 2, verify that router 1 received its public IP address via DHCP. Well, actually, we did that. What is the IP address of R1's DHCP server? We already looked at that. It is 2030.113.1. All right, now we're going to set up Cisco DHCP server. So step 4, enable the DHCP service on router 1 so it gives out IP addresses to the PCs in the 10.10.10.0/24 network. So it'd be these. Leave IP addresses 10.10.10.1, which would be the router, through 10.10.10.10 free to be assigned to servers and printers. 10.10.20.10 is the DNS server, and that's over here. All right, so we go back to the router, and we will go into global configuration mode, And we want to, the first thing you want to do before enabling the DHCP server is you want to designate the excluded addresses so that when you do set up the DHCP server, when it becomes active, it doesn't start sending out assigning addresses to hosts that should have been excluded. So start off by excluding the exclude command, which is just IP, and then DHCP, and then excluded address. And we wanted to exclude 10.10.10.1 through 10. So we will do that. So we want to exclude 10.10.10.1 through 10.10.10.10. So those addresses will be excluded from the DHCP pool that's available. And now we need to issue the command IP DHCP pool, and that's going to be for the 10.10.10.0 network, which is this one over here. So 10.10.10.0 network. And for the pool, you can name it whatever you want. We'll just call it clients. So I made a mistake. Oh, I don't think it can be capitalized. So let's do that again. Nope, I still made a mistake. So we're in global configuration, IP, DHCP, pool, and then we need to designate the 10.10.10.0. Does it not want a name? Let me see. Let's try it without. Apparently it doesn't want me to name it. I thought it did. All right, well, let's then go to the next step, which is going to be for the network, which will be 10.10.10.0 and with 24 subnet masks, so 255.255.255.0. I made a mistake. One of those days. .0. There we go. And we need to set, we have DHCP. Okay, so we need to designate the default router as this address. So 10.10.10.1. So let's do that. So default router, and it'll be 10.10.10.1. And we also need to designate the DNS server here at 10.10.20.10. So let's do that. The command is DNS server, and then you just give it the IP address. So 10.10.20.10. And that should be for that step. Verify the clients received their IP information via DHCP. Okay, so to do that, you would go to the individual clients. So in this case, the PC. We'll pull up the command prompt and we'll do an IP config all command. Take a look at that. And it looks like it did receive the IPv4 address of 10.10.10.12, so that's good. The server is 10.10.10.1 for DHCP, and then the DNS server is 10.10.20.10. So that's working. It says verify the clients can ping the DNS server by its host name, DNS server. So let's go to PC2, we'll do that there. And on PC2, by the way, we can do the IP config all command also to confirm it got its addresses, and it did. So from PC2, let's ping, and the name is DNS server. And let's see if that will work. Let's see if we have connectivity to the DNS server over here. And I'm getting absolutely nothing. So, oh, that's not, there it goes. Okay, it's working now, just delayed. So I thought I'd made a mistake, but that's okay. So that's working. So on R1, verify both clients received an IP address via DHCP. And to do that, we'll just go back to R1 and we'll do the DHCP, the show DHCP lease command. So we'll do show DHCP lease, and or no, that would apply to the router. Actually, we need to, let's do show IP DHCP pool. Let's see. Yeah, that's what we need. So it's saying 2 leased addresses have been handed out, which were for the 2 PCs, and the excluded. Okay, so that looks good. It is handing out the lease address. And then let's do the other command that's helpful with this is show IP DHCP binding, or binding. And then this command is helpful because it'll show you the MAC addresses. So this address 10.10.10.12 was given to the PC that has the MAC address ending in A359. So we did verify they received their IP addresses. And then step 8, cleanup. Remove the DHCP server configuration router 1. You will use an external DHCP server instead in the next section. So basically we just have to go and walk back the commands that we did here. And to do that, we have to go into global configuration mode, and we should be able to just use our up arrow to pull up the commands, which were the IPDHCP excluded command. So let's look for that. There it is. And we'll hit Control A to go to the beginning of the line here, and we'll just type in the no command. So it becomes no IP DHCP excluded addresses. We're just undoing that. And then we'll up arrow to get to the IP DHCP pool command, which is there. Hit Control A to jump to the beginning, issue the no command. And that should take care of that. Now it says enter the command IP config release on the PCs to release their IP addresses. All right, so let's do that. And the command is ipconfig /release. And it looks like it did it on that one. And let's go to PC2, command prompt, ipconfig release. And it looks like it did it there too. So that's done. Enter the command ipconfig renew on the PCs and verify they can no longer obtain an IP address via DHCP. All right, let's do that. So IP config renew, and let's see what happens here. We're gonna jump forward in. Okay, DHCP request failed, and that is what it wanted us to do. And then we'll do the same over on PC2, and we'll pull that up. ipconfig renew, and we'll give that a moment to see if it fails as well. I'll jump forward in time packet tracer. There we go. DHCP requested indeed fail. So we're moving on. We finished that. Now to an external DHCP server, which will be over here. It says the server at 10.10.20.10 has been configured as a DHCP server with a scope of addresses for the 10.10.10.0/24 subnet. But the PCs there are not receiving IP addresses. Why is this? Well, we took off the DHCP. Remember in this step up here, we set it up, the server as a DHCP server, but we took that off. So now what's happening is DHCP uses broadcast, and the router is not going to forward that on over here because broadcast isn't going to be forwarded by the router. And so it's just going to basically die right there. They're never going to get over there. So we need to configure the router to forward the broadcast messages over to the server, to the DHCP server. And to do that, we go to you have to use the interface where the DHCP messages will come in. So that'll be this interface here, Fast Ethernet 01. So that's the interface you'll configure this for. So we'll do an interface Fast Ethernet 01. And then the command is IP, let me move this out of the way, helper address. And then for the helper address is actually the address of the server. So 10.10.20.10. And that should be that. So that was step 11, right? The server, why is this? Okay, configure the network to allow the PCs to receive their IP addresses from the DHCP server. We did that by using the IP helper address command on this interface of router 1, so it'll now forward the DHCP requests. And verify the clients receive their IP information via DHCP. So we'll go back to PC1 and we'll pull up the command prompt and we'll do an IP config all. And when we open this up a little bit, we will see that it has an IPv4 address of 10.10.10.100, and it knows its DHCP server is 10.10.20.10, and the DNS server is also 10.10.20.10. And then let's verify this on PC2, and we do the IP config all command. And if you're using Linux or a Mac, in Windows it's IP config, but on Linux and Mac it's IF config. So let's see, it did get an IPv4 address of 10.10.10.101. It knows its DHCP server and its DNS server, so that worked. And that looks like that's the end, because then up next comes the answer key. So that's the end of that lab. We worked on the DHCP client server, and then having an external DHCP server, and setting the router so that it would allow the broadcast DHCP request to make it through. So we'll see you in the next video.